Well, thank you everybody for joining us. Really appreciate the time. Thank you, Avail. Congratulations today on the announcement. Big news. We have a great group of folks here to talk about the execution race. Maybe you know some of them, maybe you don't. So this should be pretty interesting. I've tried to be as PC as possible. So maybe what we can do is we can start off with just a very brief intro from each person. Can you all maybe begin with like quick 30 seconds about who you are, what you're building, and the execution environment your team has decided to use for its protocol?
All right, I'll go ahead and go start.
I'm looking at you.
All right, excellent. Hi, I'm Steve Landers. I'm from Say Labs. Before Say, I was leading technology for Forta. Before that, I was at Open Zeppelin. So I've been in crypto since about 2017. Say is the first parallelized EVM. We're also the fastest L1 in existence at the moment. And we're focused primarily on the exchange of digital assets. Our VM is both WASM and EVM. So we just recently had the EVM, so you have your choice.
Hi everyone, I'm Sydney Huang. I'm the product manager at Eclipse. We are building Ethereum's first SVM L2. I guess most simply put, we are putting the most performant VM on one of the highest value blockchains. That's the easiest way to think about it.
Hey, I'm Dino, one of the co-founders of Fluent. We're building a ZK WASM layer 2 on Ethereum and a rollup framework using the ZK WASM VM. We're taking the best of execution environments of Web 2 and putting it onto the best of kind of like consensus networks of Web 3.
I'm Kevin. I'm working with Monad Labs as a developer relations engineer, so you might have heard Keone's talk earlier about what we're building at Monad, but essentially first parallel EVM, optimized from the ground up. Prior to Monad, I was still on Labs core dev, prior to that I was low level embedded systems and Apple, so down on the middle.
All right, so now you know everybody. So I guess like to start, when you think about like high optimization, like execution layers, I think the first thing that everybody thinks about is TPS for high performance blockchains. But I'm always wondering like whether that is the best way to frame these discussions. We look at a bunch of chains today, and most chains don't have full blocks. The claims on TPS may not be met or even necessary for years, potentially, for like new chains. So I guess like, how do you define and measure high performance of the execution layer? Like in your own words, like how do you think about like high performance execution layers?
Same order? No.
Sure.
All right, we'll do that. So we look at a number of different metrics. I'd say I agree that I think TPS is you get diminishing returns if there's not enough traffic to actually saturate that kind of TPS. But one number we use is time to finality because really the important thing about sending, especially a high risk or high financial trade, is that you have high confidence that it went through. So for us, kind of the end-to-end, that latency is for us 390 milliseconds. And that enables interesting use cases that you weren't able to invent prior because before you had to wait for settlement, you had to wait for different layers of reorgs that might happen. So we're really focused on giving you high confidence and high performance interactions with EVM.
So I have a similar view as well in that I don't really love TPS as a metric just because I feel like a lot of times it can be easily gamified and there's a lot of nuances to what goes into TPS. In a similar vein, I think high performance, to me, especially as a product person, I really think about it from a usability standpoint, from a user experience standpoint of kind of the speed of the chain, as well as the low transaction fees and whatnot. So, are you able to enable like new use cases that wouldn't be possible on lower performance chains?
I think performance is like for some applications important to a point, and then you reach a point of diminishing returns. Like I think if there's anything, before I was in Web3, I spent a lot of time in like kind of microservices and just like different types of cloud infrastructure. If there's anything I learned from those types of environments is that for a lot of actually for most types of applications, the fine grain like performance and cost optimization actually matters like not nearly as much as just pure network effects and brand and other things. And I think that's an area that like we over-index on. Like I think that there's certainly like it's not like performance optimization like high throughput isn't important. Like it unlocks new things, but for a certain class of things where that doesn't matter, like it's just not even necessarily like the competitive dimension to like really focus on. So it's important and not at the same time.
Yeah, I think like a transaction is just like defined very differently depending on the blockchain. Like Solana transactions are just like limited in size, whereas like Ethereum transactions can be huge. And so it's kind of a messy metric in the sense of like, I honestly think the only thing it really captures is the overhead over a transaction that you have to have, because when you compare TPS, it's like, okay, what besides the transaction block did it have to do? And so how many transactions you have in that block is actually like it's a weird metric of like overhead in the block beyond the transaction. So simple TPS for transfers, I think, does kind of capture that aspect of it. But as far as like how useful your blockchain is, like I think you have to be running like real transactional data. So like one thing we're doing for our benchmarks is actually just running historical blocks of Ethereum. Like that's kind of just the most like diverse, rich data set we have currently. And so for things like that, I think TPS can be useful, but again, like it's kind of the limit of like what you care about for your application, and is speed the primary thing or time to finality is important, you know. I think it just breaks down depending on the use case.
Yeah, and I think like performance is like kind of the end state. It's like the product of like a number of other things that like kind of go into it as well, right? So like we're talking about like execution. I think sometimes people are like, oh, when did my transaction go through? Like when did my transaction execute, right? And like I think a lot of people maybe aren't as familiar with like all of those parts of the equation that go into getting to the end product, which is like performance or execution, right? In this context, like what are some of the areas? You know, I think there's like probably consensus is one. I think state storage is another, and maybe even like transaction processing is just like a pretty vague way of saying what I didn't know how to think about while I was sitting here trying to write it. So where has like Monad, for example, where do you guys think like out of those three have you spent the most time? Is it like storage? Is it
Yeah, I think our like team from the engineering side has definitely spent most time on like state access. And so like the full custom database is definitely the hardest thing to deal with, because you can have like a very fast system, but like there's kind of progressive bottlenecks in blockchains, right? Like the most restrictive is probably bandwidth, like what can actually come into your node. The second is actually I/O, like how fast can you read from the disk, and then you get to CPU time, which is like the execution layer. And so really optimizing, like even though we made like a very nice parallel EVM, it doesn't mean much if we can't like actually bring I/O up fast enough to saturate it. And so that's definitely been our biggest challenge.
how's say?
So we have something kind of similar, and I'd like to break state storage up into two problems. You have the hot live transaction state, you know, and then you also have state bloat. You know, and what is it like when you're running 10,000 transactions per second to keep up with all those transaction hashes and all those different tree structure items and that sort of thing. So what we've done is we call it StateDB, but we split it into MEM-IVL. In memory, it's hot, it's fast, and then we've decoupled the asynchronous writes to disk. So it's using like a write-ahead log, kind of like a lot of modern databases have broken up their problem space this way. And that's helped us save 60% on our archive node footprint and decrease our commit times by 200x. And it's been a major improvement on Say. It's live in DevNet right now too, if you want to try it out.
So it's a somewhat similar question, but maybe a little bit off, which is for you, Dino. What is different about the way that WASM transacts? Like how do users, when they're executing transactions or submitting transactions, on a WASM-based chain, how is that different? Like there's like something I think called like near performance, and that was like kind of right? That was a bit of I'm not as familiar with WASM on blockchains, to be perfectly honest, right? So like maybe you can just describe and discuss a little bit about like how WASM like kind of executes transactions when it comes to its blockchain architecture, or specifically maybe Fluent.
Yeah, I think that depends if you're talking about kind of like our smart contract environment, L2 versus like what's possible with our framework, which is just like much more general purpose and customizable. Like some of these things can be like configured to kind of work differently. I think what's most important is like I almost just don't want to over-index on some of like the lower level kind of implementation details of some of this stuff. Like I really do think past a certain point, what matters is like what you're enabling developers to do, and that's like a way broader design space than just kind of like the performance benchmarks and things like that. Like clearly you have to pass like a certain bar for things to work really well. But then one analogy one comparable I think is interesting is when you do, I'll go back to the cloud, right? Like people, it's very easy to be like, oh, it's all just packaging up like compute, storage, networking, and it's just like all commoditized. But then in reality, like you go to somebody, you're like, okay, well, there's a cheaper cloud. Why don't you use that instead of AWS? They're like, no. It's like, okay, why? Like, because there's so many other sticky points of bundling and unbundling of things, and there's just so even like higher up in the stack, right? If you look at like Kubernetes environments, if you think of like a more like performant or highly optimized like container orchestrator, and you're like, hey, why don't you guys change from your Kubernetes cluster to this other thing that I made? People are like, you're out of your mind. Like, no, I'm not going to do that. There's like a whole ecosystem. And I know this is not exactly answering your question, but I almost it's a hot take series, and I just want to like kind of just dispute some of like the premises that we always kind of come back to around just like pure like performance, like it being just like a commoditized like performance cost game.
Okay, so then let's do this. So execution can mean a lot of things, right? It could be like how fast you transact. It could be how you like execute on like a roadmap or a strategy. And so we have a couple different programming languages that are also being deployed across these chains, right? Say is both WASM and EVM. We have Monet that's EVM. We have Solidity. But like WASM is going to be maybe more approachable or like well understood by Web 2 developers. And then we have the SVM which is based in Rust. So like I guess like why did you guys how do you think about bootstrapping and executing on like getting more people into Web 3? And who are you kind of targeting? Are they new developers? Are they Web 2 developers? Are they like outstanding Web 3 developers that are maybe starting their own projects? Like how do you kind of think about building both the community and executing on like your strategy for like getting developers as a whole?
For me?
Yeah, go for it.
Yeah, I mean, I definitely, I think you do to some degree have to meet the market where it is, and I don't necessarily we're at a point where the sentiment is like as kind of open to exploring these new decentralized computing technologies as hopefully it will be going forward. So I mean, it's not like we're going like whole hog into trying to get Web 2 devs to just start building on this thing. I think that there's like enough differentiation and like value add that we can provide to kind of like Web3 native folks in like the very near term, and then as like our technology kind of matures and builds out over time, and we start partnering with more of like the RAS providers, and we kind of get some like key use cases under our belt, I think it makes a little bit more sense for us to then kind of shift to more like Web 2 native like teams and companies and stuff like that. But like once we're at that point, I think there's an opportunity to craft like some pretty awesome experiences when you combine, you call them like just like verifiable compute environments. Like they could be implemented as like L3s or whatever, using, for example, our Fluent base or our rollup framework. And you can blend that with the experience of like a RAS provider to basically create like a serverless like experience for Web 2 devs, where the parts of their application that are just like verifiable compute, like they don't even necessarily have to learn the like how to program the smart contracts or any of like the nitty-gritty details. I mean, they do if they want to incorporate that kind of stuff for the financial components. But like for some parts of the app, if you want to deploy like website, almost like web app front ends on chain, and like ultimately like, you know, more of just like the pure logic can be implemented in just like arbitrary code. And then you kind of blend that with some of like the RAS solutions that abstract a lot of the other stuff away, and you get like a pretty damn easy experience for like Web 2 native devs. So the reason I preface that with saying like I think it's going to take a little bit of time to kind of like warm people up to that is because it could be a dead simple experience and nobody will want to do it, like if the market timing isn't correct. But I do think that like that those types of like almost near serverless experiences for some of this stuff is actually achievable.
Okay. Does anybody else want to answer, or I can go to the next one?
I mean, obviously the most devs currently building on Web3 are EVM devs, so there's definitely like a mode to like enabling like a user experience that's like kind of seamless for EVM, and that's definitely where we started. But fundamentally, I don't actually think languages are like a mode because you're one cross compiler away from being disintermediated. And like if a blockchain or a technology is big enough, some dev who's nerdy on his weekend is going to build a cross compiler for it because he wants a different language.
And I guess, yeah, I mean, school, Steven, you guys were first in WASM, right? And then you went to EVM. So, would love your take, because you're kind of like 1, 2, 3, right? Like 1 + 2 = 3.
Makes sense. All we need is an SVM now. And then, no,
Perfect.
No, we'll do all the VMs. We launched our mainnet last August, and the biggest piece of feedback we received when we were talking to teams is, do you have the EVM? Do you have the EVM? I want to be able to put my Solidity stuff on your chain, or I can't use it because I'm not going to jump and learn how to keep a new secure contract secure. I have all this tooling, I have all this ecosystem. They wanted the EVM, so that we listened to our developers, and we went ahead and added that. WASM has a neat community. Rust is a great language. I don't really think languages are going to be a huge differentiator. I agree, I think, with the Monet take that it really, I think smart developers who are used to Web3, used to working with blockchain, the harder thing to understand is the blockchain and all the nuances thereof, dealing with gas, dealing with users, dealing with onboarding and liquidity and all these other problems. Learning a language is honestly pretty straightforward, and I think all these languages are mature and have a reasonable following, and they're not, novel in any way necessarily. So I expect EVM will continue to stay around for a while with Solidity, actually.
I'm just going to touch on that really quickly. So we've thought a lot about this within Eclipse, and of course Solidity is easier to code in, and EVM has, a pretty robust developer community. However, there are things like Neon that will support, that basically will give Eclipse EVM compatibility. And like everyone already touched on, languages actually doesn't matter as much. So, there are compilers such as Solang that will easily compile Solidity into Rust. And actually Rust is one of the most popular languages globally. And one thing that we think about in terms of developer outreach is, of course, in the near term, I think it would be a missed opportunity if we didn't build for the developers that were here now, right? So crypto native developers first. But eventually, just given how popular of a language that Rust is, we think that it will be an easier motion to kind of get to developers that are maybe less familiar with Web3.
Cool. Maybe we'll get into a couple spicy ones here for a second. So, Steven and Kevin first. You guys are L1s. Fluent and Eclipse, you're L2s. So, why did you guys decide to build an L1 instead of an L2? And what's the long-term bet you're looking to make by not being an L2?
So, I think fundamentally, you have to solve the problem of a fast environment before you stack them in layers. And even if you look at most modular systems today, normal Web 2 conglomerates, all these different SaaS providers and stuff, on their back end, they're still just running a fast computer. And the fundamental unit of account on a blockchain is a transaction, right? And a transaction requires DA, it requires execution, it requires like consensus. It requires all three parts of these things. And so before we can go and like put these in different systems in the cloud, I think we first have to build like the system that does it all correctly on like a single die, basically on a single chip, right? And if you look at that world, like I don't think there's much of a distinction between an L2 and an L1 in its long term, in the sense that like if you look at shared sequencers, they look very much like an L1 consensus problem, And these, like for Monad, it was more about providing a single base of like developer experience where you can just do everything right away, right? And if that looks like eventually, working with rollups and other ecosystems to like provide that experience outward where we can, we will. But like fundamentally at first, I think it's just like from first principles, we need to build the fast thing that's a single in-house solution that like does the single thing that a blockchain does, which is make transactions fast.
Monad L2s. You heard it here first.
So we're just jumping straight to L9, I think. Just kidding. So I think none of us would be trying to create any L really if Ethereum wasn't constrained so dramatically to its current throughput at the moment. So I tend to think L2s are working towards scaling that existing throughput problem space. Otherwise, you just use Ethereum. We opted to do an L1 because we think it's important to solve that problem space of getting a transaction through quickly. Even when you're thinking through microservices, the ideal microservice is divided vertically rather than horizontally. So I wouldn't necessarily create, let's say, a cache microservice and a storage key value store microservice, and I wouldn't necessarily create an API gateway microservice, and maybe that one, who knows. But so I tend to think app chains are a little more of an analog to microservice, but I place my bet on general purpose L1s just because I think most product developers and the service providers don't want to operate their own L1. So I do tend to think there will be general purpose L1s for everybody, but that's why we're focused on monolith, because we're trying to scale the L1.
And so I guess for the L2 teams, what are some of the benefits, I guess? Like, I think it's already been addressed before in another talk, but like, what are some of the benefits and like, why not build an L1? Like, why build an L2? And what kind of benefits do you think you're seeing and the kind of differentiation that are you offering maybe an existing ecosystem?
I think it's really hard to ignore the liquidity and the network effects that Ethereum already has. And I think to not tap into that, and that's kind of the beautiful thing of the modular thesis, right, is you can decouple all these different components of a blockchain, whether that's consensus, execution, DA, settlement. And because you get to decouple all these different components, you can really innovate at each layer of the stack. And it just seems like, and I think things would move a lot faster when you have teams exclusively focused on each layer of the stack. So why not have a modular architecture that you can actually utilize kind of the best pieces of the modular stack?
Yeah, I agree. So I feel like, to me, the key is just like loosely coupled components, like loosely coupled services. And I think it all comes back to like rate of innovation. I completely agree there. I think if you look through the lens, just as a thought experiment, if you look through the lens of like an end user of either of these systems, like user A using kind of in like a monolithic world, and then like user B in kind of like a modular world, and you have in the modular world you have dozens and dozens of kind of like competing experiments all happening in parallel, and I just think that ends up creating just like, I mean, it's harder for each individual one of them. I'm actually not trying to make the case right now from like an individual team's perspective, but like I think it ends up being way better for the end user, whether it's the end user is a developer who just needs to pick the best tool for a given task, or an end user with a certain experience that's tailored towards their specific persona, place in the world, type of company, type of industry, whatever. Like, I think that like very intense, fast rate of innovation ends up just winning out net.
So I'm going to push back on Dino a little bit, and we've had this conversation before. I think it's just fundamentally two different types of devs, right? It's like there's a reason there's front end devs and back end devs, right? And app devs just want to like go somewhere. They want to have all the tools. They want to like build it and like see their app come to life. Infrastructure devs want to like tinker with things and like put L2s together and then like offer it up as a packaged solution maybe or something like that. And I kind of just think there are like different flavors of like who's going to like this. And then fundamentally, like if we all believe in the ZK future that is promised, right? Like I don't actually think there's a difference between an L1 and an L2 because at that point you're just passing state reads back and forth. And like, what does it matter if you have your own validator?
So, can I jump in? Why are you saying that in a modular system, each dev will always have to deal with all of these different components? I feel like if there's anything we've learned from like the microservice system, it's like every app on your phone, people use the phone analogies, like every app on your phone is sitting with 15 different modules just running in the background. And like, as a user, you're certainly not experiencing them. But even as a dev, like you might just be building like one of those components and then just kind of like hooking into the rest of it. Maybe that's facilitated by some type of like third-party vendor that packages things up and makes it easier for you. But like, why do you think that dev? Like, I think ultimately ironically, the modular dev ends up having like an easier experience.
Yeah, I don't think we necessarily disagree. I think we disagree on time frame when we have this. Is that like we don't have that right now, right? And like it's very noble that you guys are like building stuff to enable that, right? That's obviously the purpose. Right, but like right now as a dev coming to build in Web3, if we have to tell them, hey, wait 5 years and then we'll have this like really easy drag and drop, thing that you're used to versus like come to a platform and build, I don't know, one of them seems a little bit easier right now.
No disagreements there. I mean, like I think it is a matter of like time frame.
There's still like so much infrastructure that like developer needs to figure out or I think about to some extent, right? Like, and I think one of the things about like it's obvious why people are building L2s, right? Because Ethereum L1 like is not that great at like performing like transactions. The blocks are full. We're getting front run and back run and sandwiched. And so we're trying to like scale. Maybe one of the things we're trying to scale is just transaction throughput. Like I think that was like the thing that people like were like, we need more transactions on chain on Ethereum. Please, let's just make that happen. And now we're maybe thinking a little bit more through that, like, I mean, have we solved the blockchain have we achieved scalability? Like, have we solved the blockchain trilemma? Like, my general sense is probably not, but I would be particularly interested in hearing, it's like 3 parts, right? It's security, decentralization, scalability. Where in each of your stacks have there been trade-offs made to achieve your end goal? Anybody can start.
All right, I'll jump in here. So with Say, instead of having 100,000 nodes validating every transaction, we are placing our bets more that verification long term is going to be the way large networks are going to be able to scale the problem space of security. So we've just made sure that it was very, very expensive to take over the network. It has to be very, very expensive. We've optimized for performance at every turn because we think there's such a target-rich environment for improving the L1. So for us, decentralization, we are decentralized. It's not a binary. So we've chosen we're on that path to be decentralized enough, and that is that nobody's able to take over the network. And that's I think our whole idea. In the future, we'll become more decentralized, especially as technologies evolve.
But do you think the blockchain trilemma or the concept of it is slightly outdated? I think, a lot of teams have made a lot of strides to kind of overcome that. If I had to pick a trade-off that Eclipse did is, I would say, so the Solana L1 is very high performant, right? To be Solana aligned, it means that it's high performance, low latency, right? That's what Totally said at Breakpoint, the most recent one. And I think at Eclipse, we have a slightly different philosophy, which is we want to preserve as much of the performance as possible of the SVM while maintaining the verifiability properties. So that's what we're getting with fraud proofs using RISC-0. We're getting light nodes from Celestia SDA.
are you guys? I think I've like kind of heard that you guys are thinking about like POA. Like there may be. It's like I think the one like knock on like decentralization maybe for like L2s is that they're like single sequencer right now. There've been some podcasts with folks on them that have said that there's like maybe a POA approach. Like is it like no L2s have more than one sequencer right now, right? So I'm pushing this to you and I'm going to push it right over to Dino. But like, is it like sufficiently decentralized? Is it like 10 sequencers? Is it 4 sequencers? Is it 1 sequencer?
I wish there was a magic number.
Do you have like a target?
I guess the number of like how we think about sequencers actually is it's not really just about the number of sequencers, because as an L2, you are inheriting certain security properties from the Ethereum L1. So for example, if an L2 sequencer were to censor, say there's a single sequencer and they're trying to censor a user transaction, the user can actually go through Ethereum L1 and force include their transactions. So the single sequencer issue isn't as big of an issue as people think it is, but there's definitely a lot of work being done on the sequencer front.
I would push back.
I was going to say something about consensus, but go ahead.
I would push back on that because like when the user has to go to the L1, then you're subject to the L1 constraints, and therefore you're not getting the core property of the L2, which is performance, right? So like if the sequencer fails, you're not using Ethereum, you're not using your L2.
I think that's in a worst case scenario, right? Obviously, that's basically if worst case scenario that happens, but day to day you're still getting kind of performance properties of the SVM.
I mean, I think there's a few trade-offs. Like one I can think of is shorter term, and then one is pretty like fundamental. The shorter term is just like sequencing improvement. Like we're going to start off and we're going to bootstrap the network, and we're going to start off with centralized-ish like sequencing improving, and then over time decentralized. So that's a near-term one. That's like we'll solve that over time. There's a fundamental one in the fact that we're a smart contract roll-up, or will end up kind of like progressively becoming a smart contract roll-up. And I think the trade-off then is like sovereignty and like, I'll say like interoperability, like practical interoperability. Because it's like, it depends, as a smart contract roll-up, when you're tapping into this like Ethereum like trade network, like I think that you will end up finding kind of like almost just like a larger customer base and like broader access to liquidity and people who, you get a higher score on like plays nice with others because you're kind of like opting into this thing, but you have less sovereignty.
Oh boy, I'm not supposed to be talking. I'm supposed to be asking questions. But like, I think one of the things one of my hot takes I think for this week is that, I think when I look at Eclipse, you're bringing the SVM to Ethereum, right? When I look at Fluent, you're bringing WASM to Ethereum. Those are two things that have not existed on Ethereum to date. When you look at the past L2s, right? Tell me the difference. Explain the difference to me. Like at a DevX perspective, right? And one of the most disappointing things I think from my perspective as someone who's been like really in love with Ethereum for a while now, is that like more work and collaboration hasn't been done to provide interoperability where like these teams that are building rollups can actually like compete on the merits and of like the focus of their projects versus like building walled gardens and then having L3s built on top of them. Like it's legit like having a sandbox at the beach and be like, no, my sandbox, like only people that I know can come in my sandbox, and the other one's like, no, only people in my sandbox that I like can come here. And you're like, we're at the beach, like it's all sand, it's all EVMs, like what are we doing here? Like work towards interoperability standards that actually require you to like do business development and actually differentiate yourselves from like the rest of the audience.
Yeah, I mean, like, to speak on behalf of mine, like, if I had to say anything, I'd say we solved the trilemma, right?
Let's go.
But obviously that has, like, like, there's nuance to that. And so, like, I think we just, like, kind of, like, picked a point on, like, and I can't say this word, but the Pedro efficient trade-off curve or whatever, where, like, we're like, okay, node requirements are, like, a gaming computer. It's not a Raspberry Pi. but from that we can squeeze like a lot of performance, like performance that where you can compete with real world systems. And like kind of making that trade-off and saying, yeah, we're still going to have a decentralized network. Maybe if you're in a third world country, you actually have to do like a business use case to like run a node between people and like, have a use case for this full node. Maybe your business built on Monad like needs the data the fastest. Therefore, there's an incentive to run a full node, and therefore, because your business is making money, you don't really care that you have to like kind of pay. Like people who use AWS today don't go, oh no, AWS is charging us something. Like they have a business use case and they're making money from that, and therefore they're okay to pay a little bit for the servers, right? I think Monad is trying to hit like a sweet spot where like, okay, maybe your CapEx cost is like a little bit more, but the network pays for itself, it's sustainable, and other than that, it's performant, right? And like just really trying to hit that like sweet spot in the trade-off tree.
Cool. All right, 5 minutes left. Rapid fire now. Let me see here. So here's a question. I know some folks are on testnet and others are live. Have you seen MEV on your chain yet? And like on the tests, and are you like, what's that like? Have you seen any MEV? Like, how concerning is MEV on like high frequency, like low latency blockchains? And yeah, just curious about MEV. You guys are live, so
Yeah, I was going to say, I have not. Well, one thing about having a very, very fast chain is that the window of opportunity for using something like a flashbot intermediary or optimizing for sandwich attacks and things is just pretty tricky. So we're watching the space. We're having interesting research discussions on this topic, but it hasn't become our highest priority compared to just making sure we're scaling the EVM.
have you seen like a lot of spam like during NFT mints or anything like that? Have you like noticed?
We did hit. We had a spike of inscriptions, along with almost everyone else. We didn't have any system impact. Block times were the same, but it was interesting to see just this flood of transactions flow through the system.
And it performed well. Congrats. And it performed well.
Yeah, we didn't
break it.
explode. That was awesome.
Awesome.
So we haven't like seen it yet because we're not live yet, but we've definitely been like thinking about this problem. And there's like some cool research questions about just the way that like hot stuff works. Is because you're sending your block to the next leader, like the next leader has the opportunity to like unbundle and steal the MEV. So there's kind of like a less of incentive to even do the MEV because you're not guaranteed to capture it because the next leader might take it from you. And so like this is obviously stuff we're gonna have to see play out, but we've definitely been like thinking about it. And yeah, it's kind of interesting. We'll see.
We're on private testnet, so we haven't really seen it.
We haven't really seen anything yet, but I think MEV on Solana looks a little bit different. There's no mempool, and of course the block times are much shorter, so it does look different. And we are kind of looking into different transaction fee mechanisms or different changes that we can do to the SVM to make it more incentive compatible and whatnot.
I've got another one. For like high performance chains, like we have, this is more of like I promised myself I wasn't going to talk about EigenLayer because why would I be talking about EigenLayer on in this conversation? But like, let me talk about it for a second, like shared security for a second. One of the reasons that I think like shared security and EigenLayer exists for Ethereum, besides alignment, is like because you just can't do all this logic and like all this compute like on the L1 and have it be able to do pretty much anything else. Like, do you think your chain, like how important is it to keep computation on chain for your chains?
I think we obviously want to enable the most rich computation environment possible. But like being Ethereum compatible, right? We also benefit from all the ZK research, right? Because like our state trees are stored the same way, Merkle proofs, like so. I don't think it's like really opinionated if you want to do off-chain compute. Like most of the off-chain research is in the EVM space, so it should naturally flow onto Monad. But besides that, I think I think eigenlayer as a concept makes a lot of sense, like even outside of like the shared security sense, in the sense that like it allows you to add consensus rules to a chain without changing their consensus. And so I actually think eigenlayer is useful as a primitive on all chains, because if you just want as a bridge or something to have some sovereign control of like what's going on the other chains, you can add arbitrary consensus rules to a limited set of validators and like actually validate that from your chain. And so imagine if you had eigenlayer on 2 chains, you could actually do like a dual sovereign bridge where each chain could actually force exit to their native chain depending on the asset.
That's cool. It's sort of like mega blocks in Cosmos. Like I don't know, like where the validators are like somewhat similar. Like where validators are actually like the same validator is producing blocks for 2 chains at the same time, and so like you can start to do verification because like it's you're not trusting anyone except yourself essentially. All right, cool. I don't have any other questions. They didn't start the clock for like 5 or 10 minutes before we started. So like I ran out of questions like 10 minutes ago. Thank you guys. Thank you everybody. Please give a round of applause to our panelists. If we want to connect with you guys, where's the best place to find information about your projects? Where should they go?
So for Say, it's say.io. There's a public DevNet, and all of our code's open source, so you can take a look at any of it. You can play with it right away. We have a parallelized EVM DevNet ready to go. So interested to hear what you think.
For Eclipse, our website is eclipse.builders, or you can find us on Twitter at EclipseFND. And we are live on testnet right now, so if you want to play around with testnet, feel free to look at our developer docs.
At Fluent XYZ on X, and we have a private testnet. The framework that I might have referred to before is not yet ready, but the smart contract L2 is ready. So if you want to dabble in that, reach out.
Our website is monad.xyz. I encourage you to join the Discord. We have a wild, crazy community. So
If you can get in.
yeah, if you can get in, like it's a fun time. Feel free to tag me, Zen Llama, in there, or just ask a question. We have great mods that'll get to us. Q2 is our testnet, and so we'll have some wheels to kick at that point. But until then, like vibe, join out, and like don't feel afraid to tag me in the Discord and ask your questions.
Well, I also signed up for Fluent's testnet, so I'll so let me in, bro. Awesome. Thanks everybody. Have a good day.